Now, unlike Blazor Server, Blazor WebAssembly is a client-side in-browser implementation of Blazor, meaning that much, if not all of the code execution work takes place inside the browser. Blazor WebAssembly allows us aspiring C# developers to create single-page applications using C# without needing to code in JavaScript. Okay, I've just thrown two bits of jargon at you, which I now need to clarify. Those are WebAssembly and single-page applications. To fully understand Blazor WebAssembly applications, it is easier to start with a discussion of what single-page applications are. The old school approach to developing web applications was the multi-page approach, where an entirely new web page is loaded and redisplayed by a browser each time the data to be presented had changed. In contrast with single-page applications, all the data for a web page is loaded once, and when certain bits of content or data on that page changes, only the changed content is updated without reloading all the components that are needed for the rendering of that page. Some examples of well-known single-page applications include Twitter, Gmail, and Netflix. Both Blazor WebAssembly and Blazor Server applications are single-page applications. Now, don't let the name single-page application fool you into thinking that the entire web application is made of one web page. It absolutely can be, but this is not always the case. And this might be confusing to you later because with Blazor Server applications, you might see lots of Razor pages in your application. But all you need to realize is that those Razor pages in your server-side application are not web pages in the traditional sense. They have the .cshtml file extension, not the .html file extension. In other technologies like MVC, which you don't have to worry about, these files are called Razor views, but still, they are not your traditional old-school web pages. What is really happening when you start up a single-page application is that there is one web page being displayed in the browser. Only certain portions of that page will be updated as you use the application, but the browser will not generally fetch and reload an entirely new page as you navigate through the web application or website. And even though technically, when there is only one web page at work, it will still feel as if there are multiple pages in your single page application, as you will see later. But again, those web pages will not be web pages in the traditional sense. They will be subsections or sub-contents of the overall page. Razor components with their own URLs that will be individually rendered the way normal web pages are. And when you navigate to those Razor component URLs in your URL address bar, it will feel as if you are navigating to an entirely different web page in the website. But actually, it will just be one or more components inside an already rendered web page that is updated when you navigate to that URL. It will not be the case of the entire web page being re-downloaded or re-rendered. This will start making more sense when we get more hands-on from parts 3 onwards in this series. Now, in the background, what makes this feature of single-page applications possible is JavaScript, because this capability goes way beyond what HTML or CSS can offer, providing rich client-side functionality that doesn't require reloading an entire web page as users take action or navigate around the app requires JavaScript and client-side libraries. All browsers come with JavaScript engines that enable the local storage and retrieval of data, executables, and libraries. Single-page applications can therefore load content very quickly, fetching data from local storage and updating the user interface more quickly. Single-page applications can be designed to run in disconnected mode, i.e. disconnected from the server. You will see more of this in part 5 of this series when we cover progressive web applications. And it is possible to make updates on the client side in this disconnected mode that are eventually synchronized back to the server once a connection is re-established. Now, you may be wondering, if JavaScript enables all of this, why do I keep saying that we don't need JavaScript skills when working with Blazor? Well, this is where WebAssembly comes in. WebAssembly is a new type of code that can be run on all modern web browsers, or any other runtime environment that is capable of executing WebAssembly code for that matter. WebAssembly was first released in 2017, and so it is still fairly new. It was designed to be way more performant than JavaScript, and its binary files are significantly smaller than those of JavaScript, so you can imagine significantly faster loading times. It is a low-level assembly-like language that high-level programming languages like C#, C++, or Rust can be compiled into. Now, unfortunately, we can't talk about things like compilation, transpilation, assembly, or intermediate languages because I want to focus on the basics of Blazor. But for now, what this means is that web applications can be written in many different programming languages other than JavaScript that can be compiled into one common WebAssembly code that all browsers can understand. And you won't need to understand how to write or debug WebAssembly code. The process of converting your C# and related ASP.NET Core code into WebAssembly will be done for you. That way, all you need to do is sharpen your C# skills to build web applications. Now, if code is going to be executed by the browser, it obviously requires that the code be downloaded into the browser from the server so that the browser can read, process, and execute it, right? This is a key difference between Blazor WebAssembly applications and Blazor Server applications. With Blazor Server, your complex C# code is run and executed on the server. With Blazor WebAssembly, execution code is downloaded to the browser. This download process begins once a user first starts or navigates to the website, and it only happens once, the first time you reach the website. A certain minimum amount of code is downloaded from the server into the browser so that the browser can take over the execution of what otherwise would have been done on the server. Now, if from all of this you think that the WebAssembly app will take longer to load upon the first start of the application, but then be more responsive thereafter, you would be absolutely correct. It is important to mention, especially for the JavaScript fans out there, that WebAssembly has been designed to complement and be interoperable with JavaScript, not be a replacement for it. And what's really great is that WebAssembly is being developed as an open web standard by the World Wide Web Consortium's WebAssembly Working Group. And there's lots of active participation from all the major browser vendors. This is a major step forward for the web because WebAssembly finally provides a way to run rich client-side code on the web at near native speeds, and this was not previously possible. So hopefully now that we've covered WebAssembly, it will make sense when I say that Blazor WebAssembly is Microsoft's new web technology that enables the creation and execution of in-browser single-page web applications. And I'll repeat this just to make sure you don't forget it. Blazor Server applications are single-page applications as well.